Hello everyone, myself Gautam Sharma. I welcome you on behalf of Sapience Education. So today I'm going to introduce you in front of you a thermodynamics topic. So before that, we need to bit introduction about the thermodynamics. What are the topics to be covered in this video? So let us discuss definition. First of all, we will define what is thermodynamics actually. After that, I will define about the system, types of system, open or closed system, isolated system. After that, I'm going to discuss about its boundary, system's boundary, wall, adiabatic as well as the thermal wall. After that, I will discuss about equation of state. After that, I will discuss about the thermodynamic equilibrium. So one by one, I will discuss each and everything. So before introduction, what actually thermodynamics is? So it is the branch of physics which deals with the exchange of heat energy between the bodies and a conversion of heat energy into mechanical energies. What does this means? Actually, we have already studied about thermal properties earlier. So let us an object is there, okay, and it has a high temperature, and the surrounding temperature is having a low temperature at all. So what will happen? The heat will start transferring from high temperature to low temperature. Now, what type of heat, how much heat it has been flowed, what are the types of law that it has been governed? So we will discuss each and everything by one. So we know that by the help of heat, we also get work. For example, there is a cooker and pressure cooker, and if there is a heat and due to heat energy, the steam increases the pressure, and what happens? The vessel of the cooker will move upward. It means that the pressure energy it means that the heat has been converted into work because there is a mechanical movement. So these type of things can be utilized by knowing the depth of the thermodynamics, how actually it works, what are the practical applications of the thermal properties. Then and the scientist the scientist James Prescott Jules. According to him, he has given some most of the theories, Joule's law as well as zeroth law. So many laws and many other important scientists has given, and according to them only we start studying. Okay, so that we will able to understand each and every topic. So again I'm teaching, making you understand that branch of the physics which deals with the exchange of heat energy between bodies and a conversion of heat energy into mechanical energy. So basically we will studies about the conversion of heat energy into mechanical energy. So how this conversion happens? Is it possible to reconvert mechanical to heat energy? What is the loss of a heat energy? So these are the things we will go through this. And there are many things. For example, when we rub our hand in our cold days, so what happens? Heat is being generated. It means that mechanical energy is being converted into heat energy. So we will study all this thing one by one. So before that, we also want to discuss about the basic definition of some of the topics, like important definition. What is thermodynamic system? So what is the system? So for studying thermodynamics, we required a system. What is actually system? It is a specified portion of the matter on which effects of a variable such as temperature, volume, pressure are to be studied is called thermodynamic system. Let us consider. Let us consider this portion we have concentrated. We have given focus on this portion. Its pressure is P1 now. Its temperature is T1. Its volume is B1. It is the state. At this state, we are studying all the pressures, volume, and temperature of the matters in this portion only. We are not considering outside what is happening. We are considering only the system in the parts inside this boundary. So that's why it is known as system. It is known as system. Okay. A specified portion made of matter on which effect or variables such as temperature, volume, and pressure are to be studied is called thermodynamic system. So let us see here. This is a system, and the remaining part in the universe is known as surrounding. See here, for example, you have taken a flask or a bottles. You have taken a flask or bottle and you are studying the properties of the gases in this flask only, and the remaining portion on the universe is called its surrounding, and the layer which separates system and surrounding is known as wall, and it is also known as thermodynamic wall. So the space other than the system is called a surrounding. So system is the portion where our focus is there, where we will study about pressure, temperature, volumes, and other internal energy as a properties. So I hope you have understood this thermodynamic system. Now let us consider what is universe. So just now we have discussed that suppose there is a thermoplast or any IC engines piston cylinder process, we can also tell there is an piston cylinder process. So the gas is inside this piston the cylinder. So the pressure is P1, volume is V1, and temperature is T1. So whenever we will heat, then what will happen? It will expand. So pressure may increase, volume may increase, temperature may increase or decrease. Anything may happen. So the studies of this gas in this portion only is known as the system, and the rest part of the all universe is known as surrounding. So universe we have taken system as well as surrounding, that constituents of this system and surrounding constitute universe. So it means that universe is equal to system and surrounding. So I am just teaching you in context of the thermodynamics. Okay, so on the context of thermodynamics, we will consider system as well as surrounding in this way. System is the portion where our focus is to be made, where our attention is to be made, and study of the gases will be there. Now see here, system. This portion, orange portion is our system. This orange portion is our system. This portion is our system. This is the boundary, and the remaining part in the whole universe is known as surrounding. And when you add this system as well as surrounding, then it will become a universe. Okay. Now, how many types of systems are there? So let us categorize it one by one. So there are three types of system. One is open system, another is a closed system, and third one is isolated system. So this type of category, what do you mean by this? Open system, another is closed system, and third one is isolated system. So let's consider open system. So open system, in this system, exchange of a mass as well as energy take place with the surrounding. Exchange of mass is happening. What type of mass happening? For example, you are taking a cup of tea. Okay, if you are taking a cup of tea, so what happens? The vapor, the content or matter of the tea or water is there in this inside a tea. So what happened due to heat and due to exchange of heat? So this water gets converted into vapor form. So it means that the sum of the matters are being going outside the system. If we are considering a cup of the teacup as a system, then outside it is a surrounding. So the mass of the system is going outside. So that when there is a mass transfer as well as heat is also being transferred, then that type of a system is known as open system, because here not only energy or heat energy is being transferred, there is also a mass transfer. So when there is a mass transfer as well as heat energy or any energy gets transferred, then that type of a system is known as open system. Now what is closed system? In this system, exchange of energy occurs only, but no mass exchange with its surrounding happens. So no mass transfers happens, and this type of system is called closed system in the thermodynamics. So let us see the closed system. When we cover the teacup, then what will happen? There is no mass transfer happens. Why no mass transfer happen? Because we have covered it. So no vapors or no matter is going outside. So whenever there is a no matter exchange is happening, so we can say that there is a no mass transfer happens. But at the same time, it gets cool. A cup of tea gets cooled down. A cup of tea gets cooled down. It means that the energy of the cup is going outside. So there is an exchange of an energy, but there is a no mass transfer. And this type of system is called closed system. The third one is isolated system. What is isolated system? The system in which neither mass nor energy transfer take place with the surrounding. In this type of system, neither mass nor energy transfer take place. For example, for example, if this is a system, if this is a system, see this is our system, okay, and it has been insulated. Insulation means what? No heat transfer happens. So if it has been insulated, so no heat transfer will be there and no mass transfer. See here, since it is a close from every side, so no transfer of mass. No transfer of mass happens. No transfer of mass happens. But at the same time, heat is also not getting transfer. Why? Because it has been insulated. So if you want to see the example, so see the example. See this example show you, if you have taken a thermoplast, you know, we know all that there is a thermoplast and it is closed. So we can say that it is a closed system. But at the same time, thermoplast has been designed in such a way that no heat transfer happens. It means that no energy transfer happens. So when mass transfer is banned, then it is a closed system. But as soon as the energy transfer has been, if there is an energy transfer, no energy transfer, then we can say that this is an isolated system. So in isolated system, no energy transfer gets happen. So that's why when we pour a hot cup of tea, so for a while, for a long period of time, it will remain hot. Why? Because there is no exchange of energy. The energy from the thermoplast is not going outside, and whenever there is a no transfer of heat energy happens, then this type of a system is called isolated system. So for being an isolation, to make an isolation, so we need to know the key point. To make any system, to make any system isolated, we have to insulate the insulate the system in such a way, in such a way that no heat transfer take place, no heat transfer take place, no heat energy or heat transfer take place. And whenever there is a no heat transfer take place, it means that it is an isolated system. Now we will talk about thermodynamic variable. What are the thermodynamic variable? So there are several properties of the system. So the any thermodynamic system can be described by the specifying its pressure, which is the properties or a characteristics of the gas present inside it. So the gas or fluid. So specifying its pressure, volume, temperature, internal energy, and number of moles. This parameter is called thermodynamic variable. Why I'm talking about thermodynamic variable? Because if we consider a gas inside a piston, if we consider a gas inside a piston, so let us consider this is a gas, this is a piston and piston cylinder. So there is a gas inside it. Okay. So if there is a gas inside it, if there is a gas molecules inside it, so it has some pressure, it has some volume, it has some internal energy U, and it has some number of moles. So how many, as well as it has some temperature. So 1, 2, 3, 4, 5 parameters are there. So this will vary if we apply a heat from outside. So when heat energy will be there, so when temperature will increase, its pressure may increase. We don't know what actually going to be happen after a while. It depends upon the situation. There may happen that there will be volume increase. There may happen that internal energy will increase. May happen, work is will be done. So there are some variables. So these are the characteristics, properties of the thermodynamic system in gas or matter, which these are the properties, or these are the characteristics which will show the state of any gas inside a system. So what are the state? For example, in which state this gas are there? So if for describing its state, we can say that it has a pressure of 1 pascal. We can say that it has volume of 2 meter cube. At the same time, we can also state that it has a temperature of 200 degrees Celsius. Likewise, so many some of the properties are there by the help of which we can assume, or we can understand what is the properties of the gas. Now, one more important thing is equation of state. So all this, whatever I am teaching you, this is very important tool to understand the basics of the thermodynamics. So before that, we need to understand all the important points. What is equation of state? The relation between the thermodynamic variable like pressure, volume, temperature of a system is called equation of state, and mu is the mole of an ideal gas. So the relation between the variables. So for example, we have already considered pressure, volume, mu, and temperature as a variable. For any gas, have a pressure P, volume V, temperature T, number of moles mu. So what are the relation between these two all? So the relation has been given by PV equal to MRT, where P is the pressure, P is the volume, and mu is the number of moles for and R is the gas constant. R is gas constant, and T is the temperature. So this is known as equation of state. This is known as equation of state. Now, one more important thing is here thermodynamic equilibrium. What actually thermodynamic equilibrium states? So equilibrium means what? So see here, before that, if there is a there is a there is a layer, or we can say there is a wall like this, and if pressure inside this is P1 is equal to 1 pascal, and the pressure at this is your 2 pascal. So when there will be leakage, so what will happen? This high pressure gas will go into low pressure zone to make it equilibrium. Equilibrium is the state. Equilibrium refers to the state in which two or more system or an objects that are in a contact with each other have reached a balanced condition regularly in the regarding the condition regarding their thermal energy. It means that if I am considering a system A, and another system B, and it has some property of pressure P1, volume P1, T1, temperature, and it has pressure P2, volume P2, and temperature T2. So what happens if there is a high temperature is high of A, and the temperature of B is very low? So what will happen? Definitely heat will start flowing from A to B, or reverse maybe to if it has B as a high temperature and it has low temperature, then what will happen? It will get reverse. Till which time heat will get reverse? The time at which the temperature of the both the parts or both the system will be equal. But the thing is that the wall should be permissible. Wall should permit the energy flow. So when the temperature will remain constant for both the state will come when the temperature of both the system will remain same, then that reached balance condition is known as thermal energy or thermodynamic system is known as thermal equilibrium. So at this condition, we can say that the systems are in thermal equilibrium because the temperature will remain constant. For example, again I am explaining you one more thing. There is a cold water and there is a hot iron rod. So if there is a hot iron rod in this and it has a temperature of 100 degree and the cold water has a temperature of 20 degrees or 30 degree. After some time, what happens? The temperature of both iron as well as cold water is reached to 50 degree. Now, either neither decreasing of a temperature happens of the iron, neither it is being increased. Now we can say that both the systems are in thermal equilibrium. Okay. Now let us consider what is boundary of the system. So as we have already discussed what is system and surrounding. Okay, so this is a system where our focus is to be studied. Whatever system may happen, it does not have a specified volume. You may take either classroom, you may take either whole stadium. So the where pressure, volume, and temperature will be studied on the that part is considered as a system, and the rest part is known as surrounding. The separating layer between system and surrounding. The separating layer between system and surrounding. The separating part between the system and the surrounding is called the boundary. And the separation part between one system to the another is called wall. So let us consider there there are there are two different system. So the wall will what will do the wall have separated these two system. Okay, so whenever any separating part is there which separate the two system, then that is known as wall. But as the system has been separated to the surrounding not another system, then that is known as boundary. So this is the basic difference between wall and the boundary. In wall, two systems are involved, but in the boundary, what happens? One system is there and rest part is the surrounding. And the separation part or the part between the system and the surrounding is called the boundary. Okay, so there are several types of boundary as well as, so I will discuss each and every types of boundary. Now, see here, A and B both have A and B are two system and both are separated by wall. We have already discussed this thing. Okay, this thing you can imagine. This is a system and this is your wall. This is the wall and this is the wall, because this wall is separating two system. This wall is separating a two system. Okay. Now there are how many types of walls are there? So adiabatic wall. First of all, I will discuss about adiabatic wall. What is adiabatic wall? Wall, the wall which do not permit the flow of energy from one to another. It may be a movable. See, no exchange of no exchange of energy happens. Energy. For example, for example, there is a again I'm drawing the piston and cylinder process. So this is a cylinder. This is a cylinder, and in this there is a gas molecules. Okay, and it has temperature of 200 degrees Celsius, and another part has a different gas and it has a temperature of 50 degrees Celsius. So now if you are watching, now if you are seeing that the temperature is 200 degrees Celsius and the temperature of this is 50 degrees Celsius, then after some time, after 1 hour, 2 hour, 5 hour, 10 hour, the temperature will remain constant. What does this mean? It means that the boundary has been insulated properly. If boundary has been insulated properly, or even wall has been insulated properly, so it means that it enables, this wall does not permit the exchange of energy. And when this wall does not permit the exchange of energy, then that type of wall is known as adiabatic wall. So the adiabatic wall is the wall which do not permit the flow of energy from one to another, and it may be movable. Yeah, definitely it may move up and down, but it won't permit the exchange of a heat energy. So I hope you have understood this adiabatic wall. Now see here, see from figure, hot body is cold body. So hot energy, heat energy is just coming back here, and it will remain cold and it will remain hot because there is a no exchange of, no passage of a heat. Heat passage is not permitted at all. So this type of wall is known as adiabatic wall. This type of wall is known as adiabatic wall. I hope you have understood this adiabatic wall properly. Now, I will discuss about the dithermal wall. Dithermal, very important. Dithermal wall. What is dithermal wall? So, a boundary through which a heat can flow is called dithermal wall. It permits this type of wall. It permits the energy flow. The energy flow. In spite of covering, in spite of boundary, it permits the heat flow. For example, if you take a cup of tea, so what will happen, and if you cover this, in spite of covering, after a while the temperature will down. Why? Because the wall of the cup is permitting the heat energy to take place. So on the basis of the same ground, dithermal wall has been made. So in dithermal wall, what happens? In dithermal wall, see, there is a hot body and there is a cold body, and it has been separated by wall. In spite of separation of wall, no mass transfer happens. See, no mass is happen because there is no hole at all or no passage at all. But at the same time, it is transferring the energy. It means that if there is a hot body and there is a cold body, after a while both temperature will become same, because hot body will transfer heat energy from this body to this cold body. So after a while, that temperature, both the temperature will remain, both the temperature will become equal. Both temperature will become equal, will become equal. I hope you have understood now. So what is diathermal? It means that it permits the flow of energy. So just a shortcut is that diathermal wall permits the permits the flow of energy. Flow of energy. This type of wall permits the flow of energy in the thermodynamic system, and this type of wall is known as diathermal wall. So I hope you have understood. So these are the basic terms. So I will go more deeper. So these are the basic terms you should must know before studying or going into the laws of the thermodynamics. So thank you for joining our class.